Good afternoon. George Hepworth, Grover Park Consulting. Let's go shopping. In part 3 of this multi-part series on building a hybrid access and PowerApps application with SQL Azure tables, we're going to go to the next step in making our gallery with collections of items more useful. Specifically, we're going to look at filtering, searching, and sorting on those collections. We do that for the same reason we would do filtering on a form in the access side. We don't want to load more records than we absolutely need in order to improve or maintain good performance. The more records you load at a time, the slower the performance can be. On a small record set, like the one we're using here, 763 records at this point, the difference may not be all that noticeable. In fact, once that record set is loaded into memory as a collection, it's barely noticeable. But as a general strategy, we always want to limit the number of records we present to the user at any one time in any way we can. And we do that by filtering, searching, and finally we improve the final presentation by sorting those collections into a meaningful look. So let's look at how this works in our shopping cart. I've set up the design interface in my Microsoft 365 PowerApps environment and loaded the app ready to work. Let's play the app and navigate to the shopping list. When the shopping list opens, you see a couple of changes from the previous version that I showed you in part 2. Number 1, I have added a different kind of filtering so that it opens with 0 records loaded in the gallery. I also put this little helper control, it's a label on the screen, and it has 2 calculated values. The 763 on the right is the unfiltered collection itself. There are 763 records in the collection. However, the filtering that's applied reduces that to 0 so that the gallery on the screen contains no records at this point. We do that by applying a filter, which I'll explain when we dive into the code. We can start by selecting Safeway. That applies 2 filters. The first filter is by vendor, and you can see that it returns only items from Safeway vendor. It also automatically applies the frequently purchased filter. I did that because my goal is to minimize the number of records loaded by default. And by filtering against frequently purchased items, I can limit that list. As you can see, 524 unfiltered, of those records which are not in the frequently purchased category. That's reduced to 82. So it should be a lot more responsive with 82 than 524. In a small record set like this, that difference is not hugely noticeable, as I said earlier. However, if you can imagine a situation where you're loading hundreds or even thousands of records, that kind of filtering could make a noticeable difference in your performance. Let's step through the other filters. We have 82 in this vendor, 21 at this vendor. And as you can see again, filtered and unfiltered. Let's leave this unfiltered. Switch to the other, and it reapplies that frequently purchased vendor. Again, I want that down to the minimum number of records by default to improve that performance. And these are then other stored. Most of these look like gasoline and so on. If we take the total of 4 and 21 and 82, that should add up to, in my math, 107. We select all, and that should be the same number. So that's how the filtering is applied, interacting between vendor and frequently purchased items to limit by default the number of items taken from the from the collection and placed into the gallery. Second level is a search. Now this is a contains search, which looks at three fields. It looks at the item name, it looks at the brand name, and it looks at the vendor name. If it finds a match on those letters, it returns it. So we can see eggs and eggs, eggplant, and bacon strips. We progressively limit the number of records as much as possible by using these filters to improve performance in the gallery. The underlying collection is not changed, only the items in the collection. And by doing the filtering on the collection in memory, we avoid repeated visits to the server to retrieve a fresh record set with a new where clause. Let's look at how the filtering is. Let's take the app out of play mode, go back into edit mode. I'm going to rerun the onStart, which will reinitialize all of the variables for the frequently purchased items and all the vendors back to the initial state that the app would be in. And as you can see, that restores us back to 0 items in the gallery. Let's look at how that works. And you can see the gallery outline. The items property of a gallery is equivalent to the record source property of a form. And it tells us which records to use, where to get them, and how to filter and sort them. When we start, we have initialized some variables. The vendor filter is initialized to the value of all, and the times bought variable is initialized to 9,999. You'd have to buy a lot of eggs to get 9,999 times bought. Filtering proceeds from the innermost level to the next level up, from there to the search, and from there to the sort. This logic is similar to what you will see in an if-then-else. Frequently purchased items then are filtered, 8 or more. The records that pass that filter from the collection are then moved up to the second level, which is the vendor filter. We filter that pre-filtered record set by whether it fits into the all vendors, other vendors, Walmart, or Safeway vendor. The results of that filtering are then passed up to the search. We're moving from innermost to outermost. And the search is applied against whatever is typed in that input field, input control. And it looks at the values in brand name, food item, and vendor to decide whether or not this value is contained in one of those. That filters or limits the number of records further. That final list is passed up to the last step, which is the sort. And it sorts on food item, and it can sort either ascending or descending depending on the value of this variable. One of the consequences of applying our filters in the sequence which we applied them is that the innermost filter, which is the first one applied, is the frequently purchased items. And we saw that that can have a significant impact on the number of records returned to the next higher level, which is the vendor filter. And so the biggest performance impact might be gained by doing that filtering at the lowest level, because it changes the number of records most dramatically. However, the downside of that is that we have to repeat it 3 different times in order to capture its impact on whichever filter for vendor is going to be used. So in this case, it has to be applied here for the all items, for the other items, and then third time it has to be written so it impacts the items for the vendor choice between the 2 major vendors. That makes for redundant code. The trade-off is, are we going to get better performance, or are we going to have more redundant code? I think on a small record set of 763 records, the impact is probably not all that noticeable. But on a much larger record set, you might begin to see a significant performance gain by doing it this way. There is an alternative. First, I commented out using the // all of the code that we just looked at that applies filtering to the collection to return items to our gallery. And I uncommented or made active this section of code, which implements the filtering slightly differently. It is less verbose because we moved the filter for times purchased outside of the filtering for the vendors. We made the vendor filtering the lower innermost level, the results of which are passed up to the times purchased or frequently purchased items filter, and that is passed in turn to the search. By moving this filter to the next level up or outside, we're able to reduce it to one time applying to results of all the vendor filters. This reduces the redundancy of the code. However, that is applied only to the returned items from the vendor filters. And so each of these inner filtering steps is going to return the entire unfiltered set of records for that vendor to the times purchased or frequently purchased filter. On a record set this small, as I've said repeatedly, I can't really see a difference in performance between these two. However, there is the potential that on a much larger record set that would make a significant difference. I'll leave it up to you to implement the two approaches in a record set or a gallery or a collection in your PowerApps environment and determine which way is more efficient. The last thing we need to do before we wrap this up is look at how this screen works to implement those filters. Well, each of these vendor filters is the same, so we can look at one and get the strategy. The other three will work the same way. The first thing it does when you check it, it has the uncheck property. When you check it, it updates this filter, the string vendor filter, to the value of Safeway, and it updates the frequent filter to the value of true, and then it sets the times bought equal to 7. Now, items in the gallery will be filtered by the Safeway vendor. They will be filtered by the frequent purchase filter, returning items that are more than 7. By the way, while I'm here and thinking about it, update context impacts this variable within the context of this screen. In that sense, I'm stretching a little bit, but I'm going to say that for our purposes as Access developers, you can kind of think of that as the same way a private variable might work, as opposed to a public variable. It applies to that variable within this screen. The other two work the same, except it just sets different values for the vendor filter. If it comes in at the very beginning before anything is set, it's going to change it to all, and it's going to filter everything by all. Notice that this particular implementation is more akin to a public variable, private variable and a public variable. Vendor filter is going to apply across the entire app. This applies within this context. And then again, applies the times, it toggles it back and forth from true to false or false to true, and then resets it according to whether we want to do frequent filtering or not. There is nothing happening here except when you enter text. That pretty much wraps it up. We saw in the shopping list gallery how we can use multi-level filtering to reduce the number of records in the record set that is passed to the gallery to improve performance primarily. Because we're working with an in-memory collection, that performance gain isn't all that obvious in this small number of records. In a large number of records, many thousands, you would see a significant difference, no doubt, by filtering. We saw that you can filter in different sequences depending on the priorities you have for either verbose code or perhaps more efficient filtering by limiting the number of records at the lowest level, passing that filtered record set up to the next level, and then finally passing it up to the search. The search operates against the results of both levels of filtering that return a smaller record set on which to search. Or, of course, you can search on the entire unfiltered record set if you want. And the final step is to sort those results into one of two sort orders, either A to Z or Z to A order. And although we didn't look at that in detail, you could sort, just like in Access, with multiple fields. We sorted on the name of the item, but you could also sort on the name of the item by brand name by name of item. We didn't look at that because that's a fairly trivial thing for you to implement on your own. I hope you have found something useful from this presentation. Try to implement concepts presented here in your own PowerApps applications. If you like what you see, please hit the subscribe button and reward me by giving me a like. Thanks. See you next time.